Hi everyone. I'm so excited to be talking to all of you today on a topic which is very close to my heart, MDM with AI. I hope you've been having a great run at the Master Data Marathon event so far. All right, so let's start. My name is Sonal. I'm the founder of Nube Technologies. We are a startup based in India, doing a lot of cutting edge, innovative work around MDM. Today, I'm going to be talking to you about some MDM challenges in a rule-based system, and areas where AI can be applied to an MDM. So this is a shipping company which has undergone a lot of mergers and acquisitions. And to add a new system to their existing MDM, it takes them more than 7 months. This is a beverage company which has an MDM for procurement, but they've not been able to master everything. So if they have to register a new vendor, it takes them 3 weeks to look up the MDM and look up their unmastered procurement other systems. This is a retail company which has roughly 15 million customer profiles. And they have 200K, roughly 200K incremental customer profiles in terms of updates, in terms of additions. And to master the incremental against the 50 million, it takes them 14 hours daily. This is a life sciences company. The first phase of their MDM rollout has taken them 2.5 years for 6 million customer profiles. A hard-hitting number here, the implementation costs of an MDM system are typically 4 times the license cost. And what that indicates is that there is a lot of hand configuration, manual coding that we are doing after purchasing the software to get the MDM working for us for our data. At the same time, so we have this MDM rule-based system, which in many cases is not able to give us the data at the speed that we want. And then we have this external pressure from COVID, where the way we are doing business, the way we are working completely has changed. There's so much digitization that has happened, and we need to be data driven very fast. We need data at our tabs. We need to be able to access the information. So COVID has really pushed us to look at other things, faster ways and more efficient ways of doing things, where we just can't rely on a coworker in our building and ask them to prepare some data reports for us. People costs have always been a challenge, and they will continue to rise. And then there is the tech challenge in terms of cloud adoption, in terms of more and more data coming in terms of AI and ML. So at the heart of an MDM system, I mean, if we have to fix something, let us understand how it works. At the heart of an MDM system, there are few key processes that run. We get data from the data silos into a central central repository. We massage the data. We say which column from which data set should go into the output. We cleanse the data. We match. By matching, we say which records belong to the same customer, to the same product, to the same vendor. Then once we have those clusters of matches, we merge them together. We say that we trust one source system over the other for some attributes. And then we build a consolidated view, which is called a golden record. Despite doing all this, setting up all these rules, there is a good element of governance, of overriding the data that is coming out, because we have more context. Sometimes the algorithms have gone wrong. So combination of both, typically we have more context and we try to adjust. And then we publish publish all this data out, the mastered entities out, to downstream applications, to the data warehouse, to our analytical and reporting tools, and to predictive analytics. Now, because the tech landscape has changed, honestly, ETL and publishing, the extraction and getting data in, and the publishing of the data is actually something that a lot of cloud services are providing. There are a lot of change data capture tools which can listen to the source and stream changes to our system. So at the heart of it is essentially for the MDM, the core piece is the data management in terms of the matching and the merging. Now, the first process when we get data into from our silos in an MDM is that we do the schemas, the mapping. So for the MDM column, first name, last name, here in this example, the CRM column could be coming as first underscore name, and the ERP column could be spelled as F name. So we want to say that, the first name column has to get values from this column in these sources. And similarly for email, similarly for mobile. And this we pretty much do by hand for every source system that we integrate. In terms of data matching, I have a sample of simple 3 records, all referring to the same individual. Just very few, 4 attributes here. And there are so many variations. There's a salutation. The name is, first name itself is missing. The typo in markers. The house number has a forward slash. One of them is missing the house number. Again, plan is spelled as plain. The second record doesn't have the country code at all. A lot of leading zeros, not spelled as +1. Leading spaces. And again, Wisconsin spelled differently. So even with 3 records, 4 attributes, there are this is just a sample of things where they could go wrong. And real life data tends to be even messier, more attributes, more variations. And there is no single field like an SSN or date of birth which we can trust, or where we can say that if these are the same, these records belong to the same individual. And if that is the case, what essentially happens is, because there's no unique identifier, we have to compare one record against every other record in the repository. So if we have 10,000 records, we have to compare against those 9999 records, and judiciously say which of them are matches. So it really blows up. If we go from 10,000 records to 100,000 records, we essentially increase the number of comparisons we make 100 times. And that is the heart of the complexity in an MDM. Now, because we can't join everything with everything, it is computationally so exhaustive, it was expensive, it is going to completely pull down our systems. So to avoid that, what we do is that we need to break down this problem of matching everything with everything, and to be able to get data in a form where matching is easier. So we do a lot of pre-processing on the data. We profile the data. We try and see what are the null values, which fields we don't need to care about, which fields are typically very similar to each other. So that kind of data profiling done by hand, a lot of reports generated to figure out what are the things we should consider while matching. Then there's the standardization, so that it's easier for us to compare things. And to do that, we will mark the Mr. So all the salutations can probably go, or the DRs can be replaced by doctor, so it is consistent. And then comparing doctor with doctor is easier than comparing a doctor with DR. So we do all the standardizations of names, of addresses, AVE to avenue, ST to street. And we define a fuzzy match key. So by a fuzzy match key, essentially what we're doing is that we, as I was mentioning, we don't want to compare everything with everything. And if we don't want to compare everything with everything, let's break that down. Now to break that down, how do we do that? We define, let's say that, only look within the zip code. If the zip codes are similar, are same, those records can be compared with each other. So there's no sense comparing, things with completely different zip codes and city codes or countries maybe. So if you are from, if the record is from India, no need to compare it with records which are in the US. And that's how you can, make a combination of fuzzy match keys and feed that. So take some time to figure that out, and then use that. Then once we have that, so we've broken the problem down, but we still need to say what is matching with what. And for that, we say that, if the first name is matching to this extent and the last name is matching to this extent, so for each attribute, we develop some scoring, and together we add those scores in with weights and derive a final score. So that is the fuzzy match process. And even after doing all this, because it is computationally pretty expensive, we do an extensive amount of database tuning. Now, besides just the matching in terms of scale, what we see is the MDM, by the very nature of the variety of data that it is trying to master in terms of products, in terms of locations, in terms of individuals, in terms of organizations, it vendors. So the, just the sheer variety is a scale problem, and the number of data sources together adds to the problem. So now that we've understood, I mean, these are the challenges that we typically face. What can we do better? Is there some way in which, we can improve on this or take a fresh look at this? So why not, as I was mentioning, why not, just take a fresh look at it? Why not take a completely different way of solving this by adopting some key new technologies which have come up? So enter AI, the superpower, which is, so what really is AI? I mean, the term is used broadly, but what we have is training data. Training data is essentially the data over the records over which we know what are their, where do they belong? Do they match? Do they belong to a particular taxonomy? Do they belong to a particular column? So we already have the values, the results for them. And then a model is essentially an, a, an algorithm or a combination of algorithms which can learn from this training data, derive those patterns, and then predict for unseen data. So that is pretty much what applying AI is. You have some training data, some data from which you can learn from, which has the labels. Then we build representations from that data, which is feature engineering. So the computer will not understand markers, but it will understand that these two records have this kind of overlap. And then what is the probability of the city being, same for matches? What is the probability of, what is the overlap between address for two records to have matches? And what is the overall probability? So that kind of representations. And so feature engineering essentially, and building a model which understands and fits this data. Now, all simple, but how do we get this training data? I mean, one of the key challenges in adopting AI is, like, where do we get the data to learn from? We may be lucky, we may have a legacy system where we already have some training data, or we can manually get some people to, do it by hand. But the manual process again is going to take months. And if that is what we were set out to do, I mean, what benefit are we getting? What benefit are we deriving? We could have rather just implemented a rule-based system. So if training data is not there, we have to be creative and build training data. And to build training data, there are techniques to do that in AI. There's this technique called active learning, where the algorithms pick out some records. So you don't have to label everything like in manual labeling. you can actually, so the algorithm selectively picks out some records, picks out some data points which a user can label, and that user can be a business user, just understands the problem at hand, doesn't need specialized technical skills. And from there, very frugally, those labels are selected and the generalization is made for building the model. Then there's this another technique called weak supervision, where a lot of functions, simple functions, are hand coded. So in the case of, say, matching, we can say that if the city is the same and the area code is the same, uh, they are probably a match. So this is a match. So you say, so let's say build out yes no functions for that. These yes no functions would not be accurate. The labels they give would be pretty noisy. But the weak supervision algorithms can work around these noisy labels and build out accurate representations, because at the heart of it, they know that the functions are built in a way that they would be noisy, but they would be correct too. So they can cancel that noise and build out a model there. So as I was mentioning that in schema mapping, what we do is that we have the source attributes which we link to the target. And this is done by hand. But what if instead of doing this, the system can start recommending to us what, by contents, by looking at the column, what, you know, what columns we can actually map to each other. So in this case, the primary contact, it has learned that the primary contact from the input can actually be mapped to the first name column in the output by contents, by looking at the contents. And how is this done? We actually can. So similarity is a very common thing that we do across all machine learnings. Like Amazon is going to look at my buying pattern, look at other users who have similar buying patterns, and be able to suggest and recommend, what thing I'm likely to buy next. And similarly, we can cluster columns which have the same value ranges, which have the same kind of values, which have the same kind of null values. So the data distributions, the number of values, etc., are same. And through feature engineering, we can cluster similar columns together. And that can be a recommendation. So it makes our job easier to add a new system. Similarly with matching, by using active learning, instead of building out everything by hand, the algorithms can select some records for us to label. And we can say if they are matches or if they are not matches. And we can, just by saying yes, no, we can train the model and build out sufficiently good, accurate rule set internally, which can do our matching for us. And how this can work is, so matching has multiple problems. One is we don't want to compare everything with everything, as I was mentioning, because that's a computationally very expensive. So when we are labeling, when we are saying yes, no, these algorithms have to learn to cluster. Instead of we doing the fuzzy match key, selecting the fuzzy match key, how we are labeling, they can pick out the pattern and say that yes, it looks like the fuzzy match key, a combination of these records or these attributes like city or country, is a good bucket to put similar records together. And then within that bucket, it can learn to classify uh, what records actually, in terms of what is the probability of the user saying it's a match with the contents of the field matching. So it can learn to classify them, whether they are matches or non-matches. And active learning I already talked about. So once we do that and we take a completely fresh take, we actually don't have to do any data massaging. Very minimal data massaging for us. It can actually learn a lot of things, and we don't have to really tune the system that much if we also run it on a distributed system. So besides these, AI can actually also be used in a variety of cases, like spend classification, where you want to understand what supplies belong to UNSPSC or E-class or a particular taxonomy. We can say that, this supply is probably a print supply, this is an office supply or a stationery, by looking at the column contents. Data quality, AI can flag which values are erroneous, because it is already doing a lot of fraudulent transaction monitoring and anomaly detection. So maybe some of those techniques can actually be applied here. In terms of data transformation and unstructured mastering, looking at records which free flowing text, and getting out values from mastering values from news feeds or articles, and enriching our data sources. That's also something that can be used by that can be done through a combination of NLP and AI. So broadly, those are some areas that we can start looking at. Now, I've mentioned that, a lot of things can actually be solved by AI, but AI is not a silver bullet. And while applying AI, we need to make sure that we are getting sufficient value out of applying that AI. Is this problem really an AI problem? Is there, I mean, is like a rule-based system, if the else condition, much easier to code, much faster to code and maintain, um, instead of doing an AI, applying AI there. Does Is there the data representative enough? So if there is an employee-employer relationship, that information, by just looking at my name or my address, column contents, you actually cannot figure out. So if there is no pattern in the data, that kind of AI model cannot really build. So it has to be a combination of whether the data has patterns, uh, can we build training data easily and quickly for that, and do we also have the expertise and the interest for maintaining this system. So AI is good, AI is powerful, but some things that we need to be careful about. And that brings me to the end of my presentation. Happy to take any questions.